Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in our lecture. In last lecture we start with unit number 3 and we studied about anesthetic drugs, introduction and two compound synthesis. Now we continue this class with synthesis of procaine. Procaine is also known as novocaine. Procaine or novocaine. In this synthesis, first of all, we synthesize our intermediate compound 2-diethyl aminoethanol and then it is treated in synthesis. So, first of all, we synthesize our intermediate compound for procaine. For 2-diethyl aminoethanol is synthesized from ethylene oxide and diethylamine. Here the structure are stated is ethylene oxide. This is ethylene tricyclic compound ethylene oxide and this is diethylamine. So first of all this ethylene oxide and diethylamine are condensed and we get 2-diethyl aminoethanol. 2 we get 2-diethyl aminoethanol. For this synthesis, it is our compound number 1. Now, we start with para-nitrobenzoic acid. Stated structure is para-nitrobenzoic acid. This para-nitrobenzoic acid is treated with phosphorus pentachloride PCl5. So we get 4-nitrobenzoyl chloride. Carboxylic group COOH. This is COOH is converted into carbonyl chloride. So we get 4-nitrobenzoyl chloride. Now this 4-nitrobenzoyl chloride is treated with our compound number 1, that is 2-diethyl aminoethanol. So we get 4-nitrobenzoic acid to diethyl aminoethyl ester. Here reaction takes place between this COCl and this OH. Hydrogen from compound number 1 and chlorine from 4-nitrobenzoyl chloride. So hydrochloric acid is removed and we get 4-nitrobenzoic acid 2-diethyl aminoethyl ester. Now this is treated with acid metal reduction in presence of iron and hydrochloric acid, iron Fe and HCl. In presence of acid metal reduction, 4-nitrobenzoic acid 2-diethyl aminoethyl ester is converted into 4-amino. It is noted that this is NO2 is converted into NH2. So we get 4-amino benzoic acid 2-diethyl aminoethyl ester. It is known as procaine or its known name is also novocaine. So procaine, novocaine or IUPAC nomenclature of this is 4-amino benzoic acid, 2-diethyl amino ethyl ester. So we from this route we synthesize procaine or novocaine. Now medicinal application of procaine or novocaine. The free ester is an oil, but it is isolated and used as the hydrochloride salt, which occurs as an odorless white crystalline powder that is stable in air, soluble in water 1s1, alcohol in 1s13, but much less soluble in organic solvent. So these are the properties of procaine or novocaine. Now, it is a powerful anesthetic, but is not as rapid in its action as cocaine. With compared to cocaine, it is very slow. Next point, it elicits an activity which is approximately one-eighth that of cocaine. It is noted that approximately one-eighth than the cocaine. Now, it is not habit forming. In cocaine, the disadvantages is cocaine is habit forming, but novocaine or procaine it is not habit forming, is non-irritant and much less toxic than cocaine. The low toxicity of procaine believed to be the result of its rapid destruction esteries in the blood and tissues. It is widely used as spinal anesthetics. It is very important point. Procaine or novocaine is widely used as a spinal anesthetics. In spinal any surgery, most of surgeons are use procaine or novocaine. Next point, procaine hydrochloride has been administered intravenously as an analgesic in the treatment of burns, for arthritis, as a substitute for morphine in post-operative care and in serum sickness. Procaine administered intravenously may be dangerous. These are the very important medicinal application and properties of procaine or novocaine. Now, next compound is xylocaine or lidocaine. Synthesis of xylocaine or lidocaine. Xylocaine is synthesized from chloroacetyl chloride and 2,6-dimethyl phenylamine. Here stated structure are 2,6-dimethyl phenylamine and chloroacetyl chloride. Condensation reaction takes place. So, removal of hydrochloric acid, we get 2-chloro and 2,6-dimethyl phenylacetamide. 2-chloro and 2,6-dimethyl phenylacetamide. Now, this 2-chloro and 2,6-dimethyl phenylacetamide is treated with diethylamine C2H5 twice NH or NH C2H5 twice diethylamine. and we get our final product 2-diethyl amino and 2,6-dimethyl phenyl acetamide, and it is known as xylocaine or lidocaine. So at this route we synthesize xylocaine or lidocaine from chloroacetyl chloride and 2,6-dimethyl phenylamine. Now, medicinal application or uses of xylocaine and lidocaine. The hydrochloride of xylocaine is used as a local anesthetics. Please note that it is used as local anesthetics, which occurs as white crystals having a characteristic odor and being freely soluble in water and alcohol. Number 2, it is a local anesthetics. Number 3, it produces more prompt, intense and extensive anesthesia than procaine hydrochloride. So it is very important. It is useful for infiltration and block anesthesia. And last, an ointment containing 5% xylocaine base in water-soluble polyethylene glycol is used primarily. It is also one of the medicinal application of xylocaine or lidocaine. Now, our last compound for this class and for this lecture. STOIN. Synthesis of STOIN. STOIN is synthesized from acetone. This acetone is treated with aluminum trichloride AlCl3. So chlorine group is introduced as substitution of this hydrogen, and interaction between acetone and aluminum trichloride we get 1 chloropropane 2 on. Here acetone ketone group is on second position, so the name of obtained compound is 1 chloropropane 2 on. This 1 chloropropane 2 on is treated with dimethylamine CH3 twice NH or NHCH3 twice. So replacement of chlorine by amino group we get 1 dimethyl aminopropane 2 on 1 dimethyl aminopropane 2 on. This 1 dimethyl aminopropane 2 on is treated with C2H5MgBr, ethyl magnesium bromide. It is also known as Grignard reagent. Grignard reagent. So our compound 1 dimethyl aminopropane 2 on is treated with ethyl magnesium bromide gives 1 dimethyl amino 2 methyl butane 2 all. I repeat the name 1 dimethyl amino 2 methyl butane 2 all. This 1 dimethyl amino 2 methyl butane 2 all is treated with C6H5COCl benzoyl chloride C6H5COCl. So the hydrogen from alcohol group hydrogen is from here is substituted by benzoyl chloride and we get our final product STOIN. Chemically, it is known as benzoic acid 1-dimethyl aminomethyl 1 methyl propyl ester. So, from this route, we synthesize STOIN from acetone. Now, medicinal application of STOIN. It is mainly used as a spinal anesthetic. This is the synthesis and medicinal application of STOIN. Here we complete our first class of drugs, anesthetics. In this class, we studied about diethyl ether, benzocaine, procaine, xylocaine, and STOIN. And next lecture, we will start with antispasmodic drugs. Thank you.